Hi and welcome to this little video. We'll be going through how to do the calculations in the Unit 2, so the BTEC Applied Science Unit 2, Level 3, first assignment. So what you'll be doing within this, a couple of practicals, you'll be doing titration and colorimetry. So as you can see from this, we'll be going through the titration one. So the first thing that you'll be required to do is part of P1, if I remember right, is being able to make up a solution. So as we can see here, we are being asked to make up a sodium carbonate solution. So around 250 cubic centimeters of, first time using this, 0.2 moles per decimeter cube solution. So in order to do that, we need to work out the mass required. We're showing the calculations we'll be using here. So the first thing we need to do is to work out the number of moles that we require. So the concentration, as we can see above, 0.2 times the volume. The volume needs to be in dm cubed. We're only making up 250 cubic centimeters. So what we'll do is 250 divided by 1000. So if you get your calculators out and do that, we can see we've got an answer of 0.05 moles. And then to get the mass required, as you can see, you do the moles times the MR. So sodium carbonate up there has an MR of 106, 23 times 2 plus 12 plus 16 times 3. Bear in mind, I'm using the pure solid here. Sometimes you may have it with water. So it could be sodium carbonate and then maybe decahydrate, in which case you would need to add the 180 from the 10 times 18 onto the MR there. But like I said, I'm just doing this example with the pure solid. So what I would do is 0.05 times by 106. And that gives me an answer of 5.3 grams. So then what I would do is obviously carry on with the practical where I would go and weigh this out. So mass of the weighing boat plus the sodium carbonate. So we'll say there the weighing boat had a mass of about 0.7. So I'd want to weigh out roughly around 6 grams because I'm aiming for this. Let's say we weighed out a little bit too much. So the mass of the weighing boat plus the sodium carbonate. So let's say I weighed out 6.2 grams. I'll say 6.20 just for the balance. And then the mass of the weighing board after the solid's been transferred, we'll say is 0.70 grams, like I said. So obviously to get the mass of the solid we've transferred there, you do 6.2, take away 0.7, and we'll say I've weighed out a little bit too much. I've weighed out 5.50 grams. Now that's perfectly fine because as we can see it's reasonably close to what I wanted initially. So all I need to do now is to actually calculate the concentration that I have made up. So if you were super precise with the balance and you did weigh out that 5.3 grams as we calculated, up to your concentration here should work out being exactly the same as the concentration you initially wanted up there. But in my case, it isn't. So what I would do is I would do the 5.50 divided by the 106 mR. And that gives me an answer of 0.0519, just the three significant figures. So that's my number of moles. And then to get the concentration, as you can see, we do moles divided by volume, so 0.0519 divided by the volume we put it into, remember, was that 250 cubic centimeters. So that's your volumetric flask. But again, convert it to dm cubed. I divide it by 0.25. And that gives me a final concentration of 0.208 with, so I just kept the full significant figures all the way on there on the calculator and that. So whether it comes out 27 or 28, I'm not too sure off the top of my head. And that is our concentration there. So that's what I've actually made up. So it's a tiny bit more concentrated than what I was initially aiming for, but that's perfectly fine as long as I know what the concentration is and I can do the calculations based on that.